All right. In this lesson, we're going to talk about prime factorization. All right. So, but first, let's look at what is the definition of a prime number, or what prime numbers are. Okay. So the prime numbers basically are numbers that they only have two factors themselves, so itself and 1. Now, what does that mean? That means they don't have any other numbers that go into them evenly. Okay, so these are the first few of them that I put in there, but you can actually type in prime numbers and Google it, and you can, there are millions of them, right? So let's look at these numbers: 2, 3, 5, 7, 11, 13, 17, 19, 23, 29. These are very basic, the first few of them, the 8, 10 numbers that you are going to use all the time. Now, let me give you example of why 4, for example, is not a prime. The 4 is not a prime because according to the definition, if 4 was a prime, it should have only two factors, itself and 1. But notice that 4 has a factor of 2. Here we go. So that's 4 is not a prime. So every time that you come across a number that other numbers can be divided into that number, that means that number is not a prime. All right. So we're going to use these numbers to write any other numbers. They'll call them composite numbers. Okay. So any numbers that are not prime numbers, they're composite numbers. And those numbers, by the way, composite numbers. So basically what that means is that the composite numbers are made up of the multiples of prime numbers. Okay, and that's what we're going to do. So let's look at some of the examples. So look at 12. First, 12 is not a prime number because we know that 2 goes into it. Is an even number, right? Even odd numbers, right? You guys remember some of the divisibility rules, right? So in this case, the smallest prime number is 2. The next one is 3, so we're going to check those right away. So the way we write 12, we're going to break it down using a branch system. All right, so that's what we're going to do. So we're going to divide 12 by the first prime number. 12 divided by 2, so that would be 2 in here and 6. And there is a kind of a multiplication in between as a branch, right? So 2 times 6 will give you back 12. All right. Now, 2 is prime. You don't have to worry about that anymore. But you're going to break down 6 again using two prime numbers. Now, again, you're going to use the very first two smallest prime numbers and then go from there. If they don't work, then you go move to the third one or fourth one. But in this case, 2 and 3, they work. And notice what we have. Basically, remember, by the way, there's a multiplication in here. So basically what you're doing is that you're multiplying 3 by 2 by 2, and 12 can be written as the product of its prime numbers. So 2 times 2 times 3, and that's called prime factorization. So 12 has been written as a product of its prime factors, 2 times 2 times 3. All right, let's do 28. We're going to follow the same rule. Okay, so first we're going to divide it by the smallest, so it would be 2 and 14, because 2 times 14 is 28. 2 is a prime, we forget about that. Now we're going to continue with the non-prime or a composite number. 14 is 2 and 7 again. All right, and notice that 7 is a prime number. You're done. So now you're going to write it as a product of these primes. So here it is, 28. Write it as 2 times 2 times 7, and you're done. Okay, so 28 has been written as product. Product means multiplication of its prime numbers. Great. Let's look at a couple of more examples. 192. So let's go through the prime factorization of 192. Okay, so here it is. We have, what do we have? Divided by 2. So we're going to end up getting 96 times 2 is 192. Now, if you can't do that, you can use a calculator. There's nothing wrong with that, okay? So 192 divided by 2 is 96. 96 is not a prime. You can divide that by 2 again. So 2 and 96, that would be 2 times 48. That will give you that. Again, if you can't do that, 96 divided by 2, use a calculator, you can get that. And then you can do that again, 2 and 24, and then 24, 2 and 12. Then we have 2 and 6, 2 and 3. So how are we going to write 192 in terms of the product of the prime? So here is 192 is written as 2 times 2 times 2 times 2, so 1, 2, 3, 4, 5, 6. So 2 times 2 times 2 times 2 times 2, that is 2, 4, 5, and 6. And then the last piece is 3. So that's what we're going to do. That's perfect. Great. 425. We're going to write that as a product of its prime. So we notice that 2 doesn't go into it because that's not a even number. 3 doesn't go into it because the law of the 3 divisibility by 3 doesn't apply. 2 and 4 is 6 and 5 is 11. 1 and 1, 2 doesn't go into 3. So 5, it is divisible by 5. So here it is. If you can't do that in your head, you just go to the calculator, you do 425 divided by 5. And what do you get? You get 85. Okay, so here you go, 5 and 85. The next, now it's 85 again, 5 and what is the another number? Now you can do it again, would be 85, just like this, 85 divided by 5. You can do that again, or you can just do it in your head and you know that it's going to be 17. Okay, so 17, and then notice that 17 is a prime, you stop. So 425 is written as 5 times 5 times 17, and you're done. Okay, that's what you have to do. Use the branch system. It's very easy, and then write each of the composite number as a product of the prime.